Okay, so this is going to be one weird video because I don't have my pen. I use a tablet, and the tablet requires a pen. I don't have it, so we're going old school. So here is a table, and we have an information, and they give us this piece of information that for every 18, the Pac-Man traveled 18 feet every 6 seconds. So I can go on my table, and on my table right here, where it says 6 seconds, 18 feet, right? So now I have a relationship, and I can use that relationship to find constant proportionality, which was that number here, right? The unit rate. Constant proportionality, the number I'm going to use over and over to multiply to get this. So this is my x column and my y, right? Dependent and independent. Sorry, the dependent. All right, we'll get to that later. So how do I find this number over here? Well, some of you might already know that it's 3, but if we remember, to find k, which represents a constant proportionality, we're going to take a y value and divide it by the x value. So in this table here, the only line where I have an x and a y value is this one. So I'm going to use those two values to find a constant proportionality. And then k, in this case, y is 18 and x is 6, so we get k equals 3. So there's our constant proportionality. Times 3, times 3, times 3, times 3, times 3, times 3. And you can fill it in, right? So do we have a unit rate? It's right here. What does that say? That for every, and it doesn't say to ask you to do that, but I'm writing it in anyway. For every 1 second, Pac-Man travels 6 feet, right? So we have our constant proportionality, we have our unit rate, and then I'm going to add on to this and just say, hey, where's my equation? My equation is, what are we doing? To find y, to find the y value, what are we doing to the x value? Well, for every single x value, we're multiplying it by 3. So that's our equation, okay? Let me lower that. This table, is it proportional? Well, if it is proportional, the constant proportionality is the same, right? So again, is it? What's our constant proportionality? So let's get used to using our formula, right? To find a constant proportionality, we're going to take any pair and divide. So let's stick to the first one. Take the y value, which is 12, divided by the x value, which is 3. And it says that the constant proportionality supposedly is 4. Well, let me put a 4 here. Does it work for each of these? If each x value multiplied by 4 give you the y value, 3 times 4 is 12, check. 5 times 4 is 20, check. 8 times 4 is 32. So that works. So this is a table that is proportional. This one, well, let's pick the easy one, right? I don't want to deal with decimals. So again, k, we're going to take a y value, 8 in this case. We're going to take the x value, which is 2. We're going to divide it. And it says that the constant proportionality between these two values at least is 4. But if the table is proportional, everything should have been times 4, times 4, times 4. Well, that's okay. 2.5 times 4 is 10. That's checked. 4 times 4 is 12. No. 6 times 4 is 18. No. So this table, not proportional. This one, well, again, if you don't like that way, you don't table that way, you can just recreate them on. So it's 0, 2, and 4. Those are my x values, my y values. So when x is 0, y is 0. When x is 2, y is 5. And when x is 4, y is 10. Is it proportional? Well, let's find out. What's the constant proportionality? Well, let's take this line over here. We're going to take the y value, which is 5. We take the x value, which is 2. We divide. 5 over 2 is 2.5. So that's our constant proportionality. Let me put it over here. Times 2.5 times 2.5. 0 times 2.5 is 0, check. 2 times 2.5 is 5, check. 4 times 2.5 is 10, check. So this table is proportional, okay? These tables are proportional, find k and the missing value. So they're telling you it's proportional. And I mean, if you look at it, I mean, we all know it's times 4, times 4, times 4, times 4, right? So, but I'm going to do it anyway to find, if you didn't know there was times 4, right? How do you find the constant proportionality? Well, it's y over x. The y value, pick a pair. In this case, I pick 3 and 12. So the y value is 12. The x value is 3. The constant proportionality is 4. Well, 3 times 12 is 4, 6 times 4 is 24, 9 times 4 is 36. And then here, something times 4 is 40. Well, we all know is 10, but if you didn't know, well, you can go backwards, right? What's the reciprocal of 4? The reciprocal of 4 is 1/4, so you can do 40 times 1/4 or 40 divided by 4, and that gives us 10. This one, gas and miles, right? So if I have 6 gallons of gas, I travel this much. If I have 5 gallons of gas, I travel this much, etc. So let's pick a pair here. So I pick where, and I'll write x and y. So to find a constant proportionality, we take the y value, which in this case is 108, and divide it by 6. And let's see what we get here. 108 divided by 6, we're going to get 18. So the constant proportionality is 18. So times 18, check. 5 times 18 is 90, check. And then 2.5 times 18, which should be 27. No, sorry, 2.5 times 18, which is 45. And then something times 18 equals 36, which is obviously 2, right? Is there a unit rate here? No, but we can do it. Hey, what's the unit rate? Well, 1. Remember, the constant proportionality is also our unit rate. So that says with 1 gallon of gas, he'll travel 18. What's our equation here? Our equation comes in this format, right? What are you actually doing to find the y value, to find this column, the numbers on this column? You're multiplying every number in the x column by what? By 18. So your equation is y equals 18x. Yeah? Okay, so let me slowly move this to the back. So it's pretty much a repeat again. On this one, use a verbal statement to fill in the table. Terry pays $4 for 2 gallons of milk. Okay, so we have a relationship. So let's use that and fill it one of the spots in our table, one of the relationships in our table. So $4, 2 gallons. So let's look here. It's 2 gallons. So if I have 2 gallons, I'm going to pay $4. So that's given to us. Okay. Says find a constant proportionality. So what is the constant proportionality? The unit rate. To find a constant proportionality, we have to look here because that's the only place where those two values are given. So this is my x column. This is my y. So to find a constant proportionality represented by the letter k, we're going to divide the value y over x, and y here in this case represented by 4. The x is represented by 2, so 4 divided by 2 is 2. So, and we knew that, of course. So 2 times 2 is 4, so I'm going to just start filling in the rest. 0 times 2 is 0. That makes sense, right? I buy 0 gallons of milk, I end up paying $0. That completely makes sense. 1 gallon of milk, I pay 2. 3, I pay 6. 4, I pay 8. So this is my complete table. What's my constant proportionality? 2. My unit rate is over here, and can I say the statement? 1 gallon for every 1 gallon of milk, I pay $2. Okay. Here, 15 Krabby Patties every 3 hours. Every 3 hours, I have no idea what they are, but then let's use that. So let me go. 3 hours is here, which means there we go. Krabby Patties. Do you know already what the constant proportionality is? Obviously you do, which is 5, right? So we can start filling it in. If you didn't, go through the process. We're going to take one of the pairs here and use the y value and divide it by the x value. So in this case, the y value is 15, the x value is 3, and that's how we got 5. So k, right, which represents the constant proportionality, is 5. So 0 times 5 is 0, 5, 10, 20. Where's my unit rate? Right here. And in 1 hour, Patrick eats 5 Krabby Babies. What in the world? Krabby Patties. Jesus. Krabby Patties. No idea what that is. In this table, determine if y is proportional to x. Explain why or why not. Okay, let's look at the, We're going to do it several ways. So let's do it using a proportion. So let's pick this pair, 3 over 10, 12. And let me write it over here. And then over here, and this is my x values, right? And this is my y values. On the other side, I'm going to write at the top is x value, y value. So let's pick another pair, 5 and 20. If you cross multiply, 3 times 20, you get 60. If you multiply 5 times 12, you also get 60. Ooh. It looks like it's proportional. Maybe I shouldn't have done that. You know what? Take that. Not the best way of finding. Let's keep it to using the constant proportionality. So let's find a constant proportionality. Pick a pair. Let's pick 3 and 12. And in 3 and 12, the y value is 12. The x value is 3. So if I divide that, I get 4. So then my constant proportionality, k, is 4. Does it work? Times 4, times 4, times 4, times 4. It does. So is it? Yes. Why? Because the constant proportionality is the same. Right? For all the value. For all x values, it's times 4, times 4, times 4, times 4. This one, is it proportional or not? Well, let me pick a pair. Doesn't matter which one you pick. Let's find a constant proportionality. Constant proportionality k, the y value is 2 and the x value is 4. 2 over 4 is a half, or if you want to use a decimal, 0.5, whichever one you want. So that's saying that, hey, it's times 0.5, times 0.5, times 0.5. What's half of 4? It's 2. Check. What's half of 6? Is 3. Check. 10 times 0.5, or half of 10. Is it 5? Yes. Is it proportional? Yes. Why? Constant proportionality. It remains the same through the table. This one, well, pick a pair. Pick the easy one. This one, sorry, let me shift the paper over. This one. K equals y over x. And in this case, y is 4. X equals 1. So the constant proportionality is just 4. So if it's true, everything should be times 4, times 4, times 4. It's true here. It's not true. It's true here. Not true. So already we have different constants of proportionality. So it only works for the first one and the third one. So this is a no. Bottom one, proportion or not. So again, this way, you got to look this way, right? And again, if you don't like the table that way, you can rewrite that again, right? Like this. Here are my x values, 12, 18, 15, 9, 4, 6, 5, and 3. All right, so let's find a constant proportionality. Let's use that pair over here, over there. And in this case, the y value is 4, and the x value is 12. And if you divide 4 over 12, you get 1/3. And don't use a decimal, because it's going to be a repeating decimal. Let's just keep it at 1/3. Okay? So let's see if this is true. 12 times 1/3, is it 4? Yes, it is. 18 times 1/3 is it 6? Yes, it is. What's 1/3 of 15? Is it 5? Yeah. And then what's 1/3 of 9? Is it 3? Yes, so proportional. Okay. This one, again, pick a pair. Let's pick a pair. Let's pick these two, 2 and 5. So k equals y over x. K equals the y value, which is 5, over x, which is 2, right? So k equals 2.5. or 2.5, however you want it. If you wrote the table the other way, you get 0, 0, 2, and 5, 4, and 10. That's the table. Times 2.5 times 2.5 is good here. It's good here. So is this proportional? Yes, it is. Well, this one, a yes, too. So, oops, sorry. I didn't move the camera. Boy. All right. This one, number 8. Is it proportional? Well, all right, so let's pick a pair. Let's pick a pair right here. Let's pick this one. So if I have x and y, right? And I'm just going to write that pair. I don't need to write anything else. What's the constant proportionality? How does this become that? Times 5. So it should be times 5, which I'll write over here. Times 5. That should be times 5. So how do we get y, right? what do I have to do to every x value to get y? I have to multiply by 5. It works here because 1 times 5 is what? It's 5. Check. Is 2 times 5 7? It fails. Is 3 times 5 is 9? It fails because that's not true. So is this proportional? Absolutely not. Okay. Now, talk about weird. You had a little more. Not that bad. It's repeated, right? It's repetition. Determine if y is proportional to x. Explain why not. So let's go and find a constant proportionality. K equals y over x. Let's use this pair here. The y value is 1. The x value is 4. So k equals 1, 4. So I'm going to write times 1 over 4 times 1 over 4, or 0.25 times 1 over 4, and this one times 1 over 4. So if I had it in this vertically, 4 and 1, 12 and 4, 28 and 7, 36 and 9. So think about it. If I multiply 4 times 1 over 4, is it 1? Yes. Is 12 times 1 over 4, 4? Yes. Is 28 times 1 over 4, 7? Yes. Is 36 times 1 over 4? Yes. The constant proportionality is the same for all these values. So, yes. 2 is, again, they're telling you that it's proportional. So let's find out. Let's fill in the table. But in order to fill a table, I need to find k. And this one's pretty easy, right? What's k? Times 3. Times 3, times 3, times 3. So 4 times 3 is 12, so that worked. And 6 times 3 is 18, that works. This is going to be a 6. And then here, going backwards, you're either dividing it by 3 or multiplying it by 1/3. It's really up to you. What's the constant proportionality? 3. Okay, so we have, what is this? Glasses and sugar. So here is the only pair that I can use to find the constant proportionality. So let's find it. So x and y, the y value is 48. So let's use the x value, which is 4. Oops, sorry, let me move the camera. Which is 4. 48 divided by 4, k, constant proportionality is 12. What does this mean in this situation? Well, we'll actually do it in a second. So times 12, times 12, times 12, times 12. And I'll either use this one, 1, right? Because that's going to help me explain the answer to the question. So 1 times 12 is 12. 2 times 12 is 24. What times 12 is 60 is a 5. 9 times 12 is 108. And then 5.5 times 12 is 66. So it's always easier if you look at the unit rate, and that makes it so much easier to explain what's happening. So that means that 1 glass of what? Glass of lemonade has 12 grams of sugar. Yikes. Sugar. Fill in the missing values. And then there they have one more extra step here. What happens when there's 177 grams of sugar? So we'll come in and add a line for the table. How many glasses of lemonade did you drink? Well, think about it. If going this way was times 12, so obviously going backwards, you can use the reciprocal, which is times 1 over 12, or you can divide by 12. It's the same thing, right? So we get 14.75 glasses. Okay. All right. Neptune loves to swim. He swims 9 laps in 2 minutes. Which table represents this? Well, 9 laps. We're at 9 laps in 2 minutes, right here. 9 laps in 2 minutes is here. 9. Okay, so these are gone. Well, actually, let's find the constant proportionality. That's just going to solve everything. So 9 laps in 2 minutes. So let's use this guy right here. So let's find a constant proportionality. So to find k, which represents constant proportionality, we're going to take 9 and divide that by 2. So our constant proportionality is going to be 4.5. So let me put times 4.5, times 4.5, times 4.5, times 4.5. Same thing here. Times 4.5, times 4.5, times 4.5, times 4.5. Well, in this table, table B, it fails. Is 0 times 4.5 4.5? No, it's not. It's 0. So I don't know where they're getting that from. So because that fails, this is not the table that, we want to use. 0 times 4.5 is 0. That checks. 2 times 4.5 is 9. That checks. 4 times 4.5 is 18. So this is a table that we want. This fails, the first one, because think about it. If the constant proportionality is 4.5, 9 times 4.5, it's definitely not 2. So we don't even have to look at the rest. So, and the last table, same thing. We can just pick anyone. Is 9 times 4.5 2? No, it's not. So the one that we want, and that represents, right, if assuming that he swims this at that constant pace, is table C. Okay. All right, this is actually not as bad as I thought. Hopefully you can see it. Use the tables to answer the following. Is the cost proportional to the amount of camping? Why or not? Well, so let's find the cost proportionality. So if we take this, right, let's take this guy over here, 6 and 12. This is our x, and this is our y value. So to find the constant proportionality, we divide y over x. So the y value is 12, the x value is 6. So k equals 2. So it should be times 2, times 2, times 2, times 2. And then if you wanted to find the unit rate, times 2. So it's saying that for 1 pound of candy, it should be $2. Let me write 2. So that's a check. 2 times 2 is 4, it's check. 7 times 2 is 14, that's a check. 3 times 2, is it 5? No, it's failed. This table is not proportional. Why? Because over here, it was not using constant proportionality, which was 2. Okay, so it fails. This one, again, pick a pair. Pick an easy pair. Obviously, it's times 3. You and I know that. But again, get into the habit of finding the constant proportionality by dividing the y value, in this case 18, by the x value, which is 6, and the k equals 3. So it's times 3, times 3, times 3, times 3. We can say this is okay, this is okay, this is not okay, this is not okay. Right? It's going to have different constant proportionalities. So is it snow proportional to the time? No. This one, make an arrow, we're going this way. Okay, is the price proportional to the amount of coffee? I have no idea. So again, if you don't like it this way, 6, 8, 14, 6 ounces, you pay $2.10, $2.80, $4.90. Well, let's find the constant proportionality. Let's pick a pair. Let's pick this one. So it'd be $2.10 over 6, and then $2.10 divided by 6. Does that even? Divided by 6 equals 0.35. So the constant proportionality is times 0.35. Now I need to take 8 and multiply by 0.35. That works. That's true. And then if I have to multiply 14 times 0.35, and it's 4.9, so that works. So is this proportional? Yes, the constant proportionality is the same for every x value and y value. Okay? Okay, same questions. So it is a proportional. It'll tell you that the table is already proportional. So find the constant proportionality and then fill in the rest. So listen, I hope everybody sees that it's times 4, times 4, times 4, times 4. So what's the constant proportionality? 4, right? The ratio of the y value to the x value. So here, obviously, it's 10, and 12 times 4 is 48. All right, just got to speed up a little bit. Here, what's the constant proportionality? So now this one, it's not not that obvious for, could be. So let's take that. Let's pick this pair here. The y value is 4, the x value is 8. What's 4 over 8 simplify? A half, or 0.5. So what do I multiply every x value? I multiply every x value by a half to get the y value. So times a half, times a half, times a half, times a half. 8 times a half, or 8 times 0.5 is 4. And obviously this is 10, and this is 7. So what's the constant proportionality? A half. This one, just a different view, right? So again, pick one of the pairs. So either you're going to use this pair or this pair. K equals, to find the constant proportionality, y over x. So let's pick this pair over here. And we have a 20 and 15, so the y value is 15, and the x value is 20. Simplify, please, because it's easier. Divided by 5 is 3, divided by 20 is, divided by 5 is 4. So if I divide this by 5, divide this by 5, I get 3/4. So here's my constant proportionality. So let me write it this way. 20 comes with 15, 4, I don't know, 8 is 6, and then this is 9. So every single one of them times 3 over 4, times 3 over 4, times 3 over 4, times 3 over 4. Okay, so 20 is 15. So 3/4. Another way of thinking about this, if you had $20 and you take 3/4 of it, that would be 15, right? What is 3/4 of 4? That would be 3. This one's already done for us. What is 3/4 of 8? It's 6. What is 3/4? 3/4 of a number is 9. So what was the original number? Right? So this one here, you can multiply. If you think about it, you can go this way. So this number I don't know times 3/4, right, equals 9. So go the other way. Let's set up an equation. Maybe that helps. So here's a number I don't know called x times 3/4 equals 9. How would you solve this? Well, you can divide both sides by 3/4 or multiply both sides by the reciprocal of 3/4, which is 4/3. So whichever one you want. So if I take that, I'm going to multiply, multiply this, right, times 4/3, because that's the reciprocal, and multiply the other side times 4/3. 4/3 times 3/4 simplifies to 1, and 1 times x is just x. On the other side, 9 times 4/3, the 3 and the 9 simplify to 3, and 3/4 is 12. And that's how I got that answer. Again, this one, fill in the table. If they're telling you it's a proportional table already, okay, so we got to find this guy here, right? The only way to find this guy is to use this pair. And in that pair, remember x and y is 64, x is 4, and 64 divided by 4 is 16, so constant proportionality is 16. So everything's going to be times 16, times 16, times 16, times 16. 2 times 16 is 32. This is a 5, because 5 times 16 is 80, and 9 times 16 is 144. That's it. So how many, so let me answer the questions. How many students are there for one teacher? Well, there's a unit rate, right? So if I go here, one teacher times 16 is 16 students. So for every teacher, for every one teacher, there are 16 students, and that's your unit rate. If there are 14 teachers, well, then you create another line here, and you put 14, and it becomes so easy because we have the constant proportionality here, so let's just multiply that by 16. And 14 times 16, is 224 students. Right, so if I had 14 teachers, I would need 224 students. Okay, hopefully I'll find my pen tomorrow. But this wasn't as bad as I thought.